Good afternoon, Algebra 2. Today we're going to be learning about properties of logarithms. So we've been learning about these logarithms and how they're related to exponential equations. And now we're going to be kind of learning how to work with these so that they do what's best for us. Because, of course, we always want our math to work for us, not the other way around. So, logarithm of 1, just to start out, your first definition, is for every base b, log base b of 1 is 0. And the reason that is because, well, if we write this as an exponential, we'd have b to the 0 power, and we'd kick the 1 out that way, is 1. So anything to the 0 power is 1, so that makes sense. So every base b, if you take the log of 1, it's going to give you 0 every single time. Okay, so that's one property we get to remember, just something that might make our lives a little easier. Now log base b of b to the nth power says for every base b and any real number n, if we have log base b of b to the nth power, well, that would be just n. And the reason that is because let's write that as an exponential. B to the n, or b would get the nth power, so b to the n is what it would become. And then this b to the n, poop, would pop out this way and be b to the n. Now b to the n is b to the n. Well, that makes sense. So that means, remember, if bases are the same, we can get rid of them. And so that we would just have n equals n. So this whole thing would equal n. And that's what happens here, and that's why that is. So for instance, let's throw numbers in here so it looks a little more familiar to you. If you have log base 4 of 4 to the third power, well, when you evaluate that, that is just going to be 3. Okay, you can forget about doing all of the extra stuff. It will be 3. If you do all the extra stuff and write it in exponential form, etc., and get there, you'll still get to that 3 number. Okay. I know I'm throwing a lot at you here, but we have one more product property to learn about for now, and it's our product property of logarithms, and it says for any base b and any positive real numbers x and y, we know if we take log b of x times y, that's going to be log base b of x plus log base b of y. And essentially that also goes back to exponents. All right, remember our EMA thing a lot of you liked? So if we are multiplying our bases, we add our exponents. Kind of the same thing here. Since we're multiplying in here, we can split it up into 2 different logs and add them together. Okay, and this is going to work both ways. Sometimes they'll give you this piece and have you go back to writing it as a product. Sometimes they'll give you the product and have you write it as a sum. So just remember, it's kind of like our exponent stuff, except it's for logs here. So this one kind of goes, all right, well, if I'm multiplying here, I would take 2 separate logs and just add them together. Okay, so hopefully you got all these down. If not, go ahead and pause the video, and in the next slide we're going to see how these all work. Okay, first situation, we're evaluating log base 4 of 4 to the 15th power. Now this is our log base b of b to the nth should equal n. Okay, so we already know our answer is going to be 15, so we can actually just write that. So log base 4 of 4 to the 15th power is going to be 15. Okay, so that's our answer, but I want to show you why. Okay, so before, when we were doing these, let's take this down here, and I want to show you why. So log base 4 of 4 to the 15th power equals some number we don't know, so we call it x. Okay, writing this as an exponential, just like we always do, we put the 4 to the x power, so 4 to the x power equals, and remember this 4 to the 15th gets kicked out here, so 4 to the 15th. Well, we already know our bases match, so get rid of those, and you could say, all right, x equals 15, which is the same answer we came up with up here. So x equals 15. It works if you do it longhand way, but we now know a shortcut that just says, okay, if these match, your answer is just going to be 15. If you do it the long way and show me all this work, I'm not mad at you, but this will help you if you can remember the shorthand. Okay, so if you don't want to write all this, you don't need to, because now we know a property that takes care of it. Next example, we're going to find log base 6 of 2 plus log base 6 of 108. Now this is going to be our product property of logs that we're going to use here. And remember, if we're adding 2 separate logs together, now they have to have the same base. Our bases match here, so that's fine. What we can do is we can put them together as one log, so log base 6, but instead of doing 2 plus 108, we would say 2 times 108. Okay, so that is by the product property of logs, and if you need to look back in your notes for that, go for it. And we just need to figure out what 2 times 108 is, so that would be log base 6 of 2 times 108 is 216. So you don't really need these parentheses once you've multiplied, so we could just write it as log base 6 of 216. And what is that? We don't know, so this we have to do the long way. So take this, write it as an exponential. So 6 to the x power equals 216 gets kicked out, 216. 6 to some power gives me 216, so 6 to x equals 216. We need to write this as 6 to some power though, so I don't know that one off the top of my head. I know it's bigger than squared, so let's start with cubed. So 6 cubed. Oh, there you go. So 6 cubed is 216, so we replace the 6 cubed, goes in place for your 216 here. So that way we would have matching bases that we can get rid of, and we would just have left over that x equals 3. Okay, so we found what this is. Don't say x because they didn't give you an x to start with, so you would say all of this junk. So log base 6 of 2 plus log base 6 of 108 gives you 3. Okay, so this is a true statement, we could say, by all the work that we just did. Okay, so we have our quotient property of logarithms, which says for any base b and for any positive real numbers x and y, it says if we have the log of one thing and we are saying x divided by y, well, just like before where we had the product, we could add them together. Let me get my pen here. Now we're going to have the quotient, which means we do the opposite of addition, which means we're going to subtract them. So if we go back to EMA, remember, and we had division and subtraction on the other side, that's essentially what we're doing. And these you can go both ways with. So if they give you this piece, you're going to go and write it as a single log. If they give you this as a division, you can write it as 2 separate logs. You can go either way. Okay, so that's our quotient property. Pretty easy to remember if you can remember the product property. Okay. Last one is our power property of logs, which says for any base b and for any positive real number x, if we have log base b of x to some power, now be careful. We're going to actually bring this number out front and put it out in front here, so we would have n times log base b of x. Now we can still use our EMA scale here, and it is an exponent, and we do end up multiplying, so it's n times all this junk. So these rules still do apply here. This thing is kind of nice, but you want to put it out front. You never want to write this as log base b of x times n, because then you're going to take this whole log, and you don't want to do that. You want to take the log of x and then times n, so that's why we write the n out front. Okay, so a lot of rearranging with logs. Hopefully you've written down these 2 properties because you're going to need them for tomorrow, and if you don't understand, you can either rewatch or ask me in class tomorrow as well how these work. Let's go ahead and use them though. So example 3 says, recall that the formula d equals 10 times the log of n over 10 to the negative 12th power, so quite a formula here, is used to compute the number of decibels d from the sound intensity n measured in watts per meter squared. Use the quotient property of logarithms to simplify the original formula. Okay, so I'm just going to go ahead and copy our formula down here. So we have d equals 10 times the log of n divided by 10 to the negative 12th power. And it already tells us to use the quotient property, so we know that we're going to take this quotient and write it as 2 separate logs being subtracted. Okay, now be careful because we're doing 10 times this whole log, so what we need to do is we need to say 10 times, and since we're writing 2 separate ones, we need to make sure they both go in parentheses. Okay, so how this works is we're going to take log of n divided by 10 to the negative 12th power and rewrite it as the log of the numerator, so log of n, minus the log of the whole denominator, so log of 10 to the negative 12th power. Okay, so you might think, hey, this is simplified as I can get here, but not quite, because if you notice, we have log 10 of, or excuse me, log 10 to the negative 12th power. Now, I'm just going to take that off to the side over here. So log 10 to the negative 12th power, and I want to talk about it for a second, so ignore all the rest of the stuff. Notice this is just a log. It doesn't have a base, so it is implied that our base is actually 10. So going by our other property we learned earlier today, we have log base 10 of 10 to the negative 12th power. That's going to equal negative 12. Okay, so we know from that other property that these all can go, and our answer is really just negative 12 here. So the whole log bit we can get rid of and just replace it with negative 12. If you need to rewrite this in exponential form to see how it gets to negative 12, be my guest. But that is going to be our answer. So I'm just going to replace what we had here with negative 12, which is what that is. So D equals 10 times log of n. This thing we can't do anything with because we have no idea what n is. Minus, and then instead of this stuff, I'm putting in a negative 12. So minus a negative 12. Let's clean that up a bit. Boom, ching. Becomes a plus. So we have D equals 10 times log n plus 12. And then, even so, let's go ahead and distribute this 10 to make it even simpler. So we end up with D equals, remember when we distribute this to the log, it goes out front. So 10 log of n plus, and then 10 times our 12 would give us 120. Okay? So this actually very much easier than what we started with. It's very much simplified, which is kind of nice for us. We only have to worry about this n here and no division. We just add and the 10 being multiplied right here. So much simpler, I think. If you didn't follow that, please go back and watch it again. And if you have any questions, make sure you ask me tomorrow. We have 2 more examples that I'm going to save for you for the next video, so I'll see you in a jiffy.